Welcome to Mickey Study Circle channel. In this video, we shall see how to create a part modeling of the outer race, which is one of the part required for the ball bearing using the SolidWorks software. So let us begin with selecting a new part file. Now let us proceed towards creating the sketch of the part that we require. So let us select the right plane and go for the sketch option in the right plane. So now we are in the sketch mode. As you can see that the toolbar relating to the sketch is activated. So now since the outer cage is composed of a circular tube like structure or a hollow tube, we can consider that we can create the part by making two concentric circles. So ensure that the unit is in mmgs and let us create two concentric circles by keeping the center of the circles at the origin. Use the escape key to come out of the circle option. Now let us go for smart dimensioning this circle. So let us tell that the outer diameter of the circle is 52 mm, followed by the inner diameter, which is equal to 41.75 mm. So this is the first part of the sketch wherein we have created two concentric circles. So now we'll just move out of the concentric circle option and then we'll exit the sketch mode. Now we'll go to the features and we will select the extruded boss or the base option, and now you can just see that it is by default selecting the profile and it is showing the extrusion in this direction. However, we will change the direction from blind to mid plane and let us ensure that it is having a thickness of 15 mm. So you can just see that from the mid plane it is creating a protrusion in both the directions in a symmetric manner, that is 7.5 centimeters here and 7.5 mm here. So the total width or the thickness here is equal to 15 mm. So now just click OK, and now you can just see that the part is ready. So now let us go for assigning the material for this. So just click on material and select the material and then right click on this. So we'll get the edit material option. We will assign the material as the steel of type AISI 304, and now click on apply and click close. So now you can just see that the appearance of the part has been changed. So this tells that the material has been added. So now let us go for creating a cage or a revolved cut inside this profile so that it will be useful for housing the balls which are a part of the ball bearing. So now we'll go for creating the sketch. So before we move on to that, now let us select the front plane option and then go for the sketch window on the front plane. So now we'll be getting this profile. But however, we require a reference line, and to select the reference line, what we can do is we're going to change the display style from shaded with edges to the hidden lines or the wireframe model. So we'll select the wireframe model. So now we are going to select the circle option, and now let us simply create a circle of any arbitrary radii. So come out of the circle by using the escape key. So now just take your cursor and click on the center of the circle and also the origin point and ensure that they're made vertical. So the first constraint is defined. Click OK. So now you can just see that the circle is moving only in this direction and the movement in the x direction is arrested. So now what we can do is we'll go for defining the diameter of this circle. So let us tell that the diameter of the circle is around 10.5 mm. So this is the diameter of the circle. But however, still the movement in the y direction is not yet arrested. So for that, what we need to do is let us go for smart dimension again, select the circle option and select this reference edge. So now you can just see that the constraint is like arrested, and the movement is arrested, and that is why you will be getting fully defined here. So now we'll just change this dimension to 7 point say 05 mm. But however, you can just see that we require a distance between the outermost part of the circle, that is this arc and this line. So what we can do is we'll just click OK we'll select the dimension again. We'll come to the leader option, and here there is a condition called as arc condition, and let me select minimum here. So it is showing the distance from this part of the circle to this line. So if I just go for maximum, it is going to consider the distance from this part of the circle to the line here. So what we will tell is we'll select the minimum distance. So now just double click on this dimension and enter this distance as 1.875 mm. Click OK. So it is rounded off to 1.88 because here in the precision we have just given the decimal place up to two places, so it is rounding off 1.875 as 1.88. So now click OK. So you'll be getting this minimum arc condition only when you select the circle and the line. So if you just happen to see here, suppose if I select if I just have to repeat the step, let me just undo this. So now let me select the smart dimension. If I'm selecting the center point and this line option, it is only defining the distance of the center point from this line. So when I tell OK and come to the leader option, I will not get this condition of minimum arc condition. So for this reason, what we have to take care is we should select the circle profile and then this line in the dimension. So let me click on the circle and then this line. So now it is going to consider this distance. So I'll change the distance to 7.05 mm. So now I'll come to the leader option. So in the arc condition, I'll select minimum arc and then I'll change the dimension to 1.875 mm. Click OK. So now I'll just ensure that it is done. So one more precaution that I need to take here is if I just create here, you can just see that the circle is, like still beneath this inner circle. So I cannot create a revoluted cutout. So I want the circle to go protrude or interfere in this profile of the inner diameter. So what I'll do is, let me just come to the front plane. Let me just select this dimension, and here you can just see that reverse the sense of the dimension. So the moment I tell reverse the sense of the dimension, you can just see that the circle, the minimum distance is moving towards this side, and the circle is, like interfering inside the inner diameter. So I'll just come back to the front view. So now I need to cut this profile in the inner diameter. For that I require a reference line. So I'll go for line option, select for construction, and then draw the axis line of any arbitrary length from the origin. So now this completes my sketch. I'll go for the features option and then I'll take revolved cut. So now it is by default telling, the axis of revolution is this, and this is the profile that is to be, used to create the revolve cut. So I'll click OK. So now you can just see that the revolve cut has been done. So let me just switch over to the solid mode from the wireframe mode. So now you can just see that. So this is the revolved cut that has been created inside the outer race part. So this is the part where I'll be housing the rolling elements, that is the balls of the ball bearing in the final assembly. Now that we have created a revolved cutout to house the rolling elements of the ball bearing, now we need to create a groove on both the ends, that is this surface and as well as this surface of the outer race. So the purpose of having these grooves is to prevent the dust particles or any other foreign particles entering into this revolved cutout that we have created, so that they're not damaging the surface finish of the rolling elements that are in contact with this inner surface. So for that purpose, what we need to do is, again we'll be selecting the front plane and the sketch mode is selected, and now we can go for the normal too. So now we are in the sketch mode. So again let us switch over to the wireframe model. So we need to have the grooves on this and the surface. So for that, what we can do is we'll just go to the front plane and select the sketch option. So you can just see that once the plane is selected for the sketch, you get this origin symbol. So now let us select the corner rectangle option and randomly place a rectangle like this. So come out of the rectangle option by using the escape key on the keyboard. Go for the smart dimension. Ensure you are in MMGS mode. So now let us assign the depth of this groove to be equal to 0.63 mm, and then the length of the groove to be equal to say 1 mm. But still you can just see that like it is not completely defined, it is still underdefined. So you can just see which parameter. So this is the two lines. So for that we need to define the distance of this from the outermost edge. So now you can just see that it is fully defined, and this distance will be equal to say 0.5 mm. So this is the dimensions that we use to create the inner groove. So this is the revolved cut that will be created, and we require this profile on this region too. So for this purpose what we can do is we can just go to the line option, select for construction purpose, and simply draw a vertical line like this, so that it is taking the reference for mirroring. And also we'll draw one more line for construction from the origin, and let that be in the horizontal plane like this, that is in the x direction, and this line in the y direction. So this is used for the revolved cut axis, and this axis line is used for mirroring option. So now let us just go for mirror the entities. So it is asking the entities to mirror, so I'll just simply select all these lines. So you can just see that line 1, 2, 3, 4 all are selected for mirroring, and it is asking to mirror about. So tell mirror about this axis, and ensure that the copy option is selected. So now click OK. So now you can just see that the entire profile is like mirrored about this particular axis line. So now we are done with the sketch part, and we shall move on to the adding the features. So that feature is nothing but the revolved cut. So now go for the features and select the revolved cut option. So it is asking the axis of revolution. So select the axis of revolution as this line 8, and by default it is showing in yellow color what is the profile that you're going to get when a revolved cut is applied for the part. So now click OK. So now you can just see that the revolved cut is created. So this is still in the wireframe model. So let us switch over to the solid model. So now you can just see that the cutout is created. So this is the cutout that is created, and this is the uh, cage. This is the inner cutout of the race, where the rolling elements shall have a surface or a point contact. And here these are the grooves that is created. Correct. So this is the grooves that is created. So this is the inner cutout, and this is one more groove that we have created on the either surface. So this completes the creation of the outer race part. So basically it is nothing but a hollow cylindrical part which is having three inner cutouts, that is this part and the two grooves on either side. So this is how we create the outer race part. So with this we complete the creation of the part model of the outer race. So basically we need to remember a few things here, that is like how to create the revolved cutout, and how to use the commands of minimum arc distance, and also the moving of the circle towards the outer profile, so that it is having a revolved cutout within the material. And we have assigned the material of AISI 304, which is one of the grade of the steel that is used in the manufacturing of the bearings. So with this, we end up the video that details about the creation of the outer race part. Thank you all for watching.